Hi, my name is Azidan Arumugam. I'm from PMNAS1/1 and my match number will be B09181019. So today I'm going to present my bachelor degree project 2 in the title of Tensile Properties of High Density Polythene Exposed to Biodiesel. And my supervisor is Encik Hairul bin Bakri. So before we move on to next slides, I would like to welcome my panel who are going to examine me. So for introductions, high density polyethylene or HDPE is a thermoplastic polymer made from petroleum, and HDPE is used in a wide variety of applications including plastic bottles, shampoo and storage tank. So biodiesel properties, the trans-esterification process is a reversible reactions and carried out by mixing the reactant, which is fatty acid, alcohol and catalyst. So this is the process called as trans-esterifications from triglyceride, ethanol. And here is the catalyst, and we get the mixture of fatty esters and the glycerol. So what is fatty acid methyl ester FAME? So FAME is a group of organic compounds that can be synthesized through the process of esterifications of fatty acid with methanol. So however, biodiesel is in a supercritical field, can cause a fuel degradation. So in this study, several experiments have been proposed to study the properties of HDPE when exposed to biodiesel. So as for the problem statement, storage tank made up of HDPE undergo process degradations and decreasing trend. An HDPE storage tank may be failure by external factors such as stress pack caused by heat and pressure, but however, HDPE storage tank that contain biodiesel has low performance and due to the exposure of biodiesel to HDPE. So this the picture shows that the storage, the crack produced on the surface of the HDPE. So for the objective and the scope, so the objective of this project is to determine the tensile and other properties of HDPE immersed in palm oil biodiesel and to investigate the effect of biodiesel concentrations on the performance of HDPE. So the scopes that we need to achieve is concentrations of palm oil biodiesel are B10, that means 10% concentrations of pure biodiesel and 90% of FAME, and 30% concentration of biodiesel and 70% of FAME is for B30. So the storage temperature under 27 degrees Celsius or room temperature and 50 degrees Celsius. So storage duration is up to 336 hours or approximately 2 weeks. So for experimental, the material we use is biodiesel. So we use B10, and B30. So for the samples, we use HDPE. This is the raw material of HDPE. So after injection molding, the specimen will become like this. Okay, this is the dot bone shape for tensile test, and this is the shape and dimension. This is for tensile test. So we fix according to the standard, and this specimen for hardness test, we also fix the dimension according to the standard. So for the experimental, so number of samples for tensile and hardness test. For HDPE before immersions, we take 10 samples, and for hardness test is only 1. And for B10, in 2 different conditions, we take 10 samples for tensile and 1 samples also for hardness. When it comes to B30 under room temperature and 50 degree temperature, similar, we take 10 samples for tensile and 1 samples for hardness test. So the picture shows in the screen on the right side is ASTM D38-14. That means it is standard. According to the standard for tensile test, we use instrument flow mounted material testing. According to the standard ASTM D638-14, and the cross head speed is 5 mm per minute. And for hardness test, we use viscous hardness tester. we fix the dimension according to the standard of D785, and the holding time is 90 seconds, and the pressing force is 0.5 Newton. So for sample preparations, HDPE specimen was prepared using injection molding machine, and the HDPE hardness and tensile specimens were cut according to the standard dimension of ASTM D785 and ASTM D638-14. So ASTM D638-14 is for tensile, and ASTM D785 for hardness test. And this picture shows that the samples, the specimen after injection molding. Okay. Secondly, in meteorology, we undergo immersion test. So in immersion test, we use temperature control oil bath, which is we fix the temperature to 50 degrees Celsius, and we use oil bath at room temperature. So the HDPE specimen is immersed in the container that exposed to biodiesel for 336 hours, or approximately 2 weeks. The immersion test is conducted using biodiesel of B10 and B30 in 2 different temperatures of 27 degrees Celsius, or room temperature, and 50 degrees Celsius. So the weight of HDPE specimen is recorded before and after the immersion test. So the pictures show that the samples before and after the immersion under biodiesel. Okay, so the result for result and discussion for the weight. So we can conclude that the weight of the samples under 50 degrees Celsius is increased from week 0, that means before immersion, till week 2. And when it comes to room temperature, the weight is still the same, still similar, that means it increased from before immersion to week 2, but there is a small changes on the sample, on the average sample of B30 under room temperature in week 2. That means the weight is dropped slightly, 0.01 gram when compared with week 1. So it shows that the samples gain less weight when immersed under room temperature. So when it comes to the hardness test, when it comes to tensile test, and this is the result before immersion test. This is the average, and from here we can obtain the average of tensile stress, 21.25 megapascal, and the strain is 0.17, and when it comes to Young modulus, is 0.12 gigapascal. So from the graph, we can know that the load magnitude of the material continue to increase. The linear elastic limit will be breached, and the material will begin to plastically deform or yield, and in these positions. And the necking occurs after the material has experienced the maximum tensile stress and is depicted as the downward slope portions of the stress strain is called the curve. So the last point of the curve where the material finally snaps, that means it deformed. Okay. And when it comes to week 1, the result of tensile test in week 1, this is the result under room temperature, and this is the result under 50 degree temperature. So from here we can conclude that the Young modulus of HDPE samples B10 RT under room temperature is higher compared from the other HDPE samples, and the HDPE samples of B10 RT more stiffer compared with other HDPE samples. So the high Young modulus change the shapes only slightly. And when it comes to the result in week 2, we can conclude that the straight strain graph for B10 and B30 under immersion in room temperature is decreased compared with immersion under 50 degree temperature. So the Young modulus of HDPE samples B10 T50 is the highest among other HDPE samples. And lastly, this is the hardness test result. So from here we can conclude that the biodiesel the 10% under 50 degrees Celsius shows the highest decrement value, and the biodiesel 30% under room temperature shows the lowest decrement value. So from here you can conclude that the higher the temperature of the immersion, the higher the decrement value of hardness test. So, for the conclusions, all the objective from the experiment was studied and achieved at the end of the experiment. So, from the experiment, we can conclude that the tensile and hardness properties of HDPE immersed in palm oil biodiesel was evaluated at the end of the experiment, and the 30% concentration of biodiesel gives more effect on the performance of HDPE compared with 10% concentrations of biodiesel. So that's all from me. Thank you.